Have you ever wondered how Google Maps know your exact location? Well, the secret behind it is GPS technology. In today's project, I am going to show you how I interfaced a NEO-7M GPS module with an Arduino Uno and displayed real-time GPS data on OLED display. The interesting part is that when I first connected everything, I was not getting any GPS coordinates at all. The OLED was showing invalid values, and I thought there was something wrong with my wiring or code. But after connecting the GPS antenna and waiting a few minutes, seconds under the open sky, the module successfully logged onto satellites and started displaying accurate location data. So in this video, I will show you a complete setup, explain the code and demonstrate the live results. So let's get started. For this project, we will require the following components: Arduino Uno, NEO-7M GPS module, SSD1306 OLED display, jumper wires, and breadboard. Before connecting the module, let's have a closer look at the NEO-7M GPS module. On the front side of the module, the most noticeable component is the white square ceramic GPS antenna. This ceramic antenna is responsible for receiving signals from GPS satellites orbiting the Earth. The quality of the received signals directly affect how quickly and accurately the module can determine its location. On this side, we can also see the connection pins labeled VCC, ground, TX and RX. These pins are used for interface the GPS module with the Arduino. The VCC pin provides power to the module, ground is connected to ground, TX sends GPS data to the Arduino, and RX can receive serial commands if needed. On the back side, we can see the new 7N GPS chip, which is the main processor responsible for receiving and decoding satellite signals. Surrounding the chip are several resistors and capacitors that help with the signal filtering, voltage regulation and stable operation of the module. We can also see the PPS LED, which stands for Pulse Per Second LED. This LED provides a visual indication of GPS status. When the module starts receiving satellite signals and obtain a GPS fix, the LED begins blinking at regular intervals. Another useful feature visible on the backside is the USB interface. This interface allows the GPS module to be connected directly to a computer for configuration, testing and monitoring using GPS software without requiring a microcontroller. Overall, the new 7M module is compact and powerful GPS solution that combines the ceramic antenna, new 7N GPS receiver chip, PPS status LED, USB interface and supporting electronic components on a single board. Now I am going to connect the GPS antenna to the new 7M GPS module. This antenna is very important part of the GPS system because it receives signal from the GPS satellites. Without connecting the antenna, the module may not be able to receive satellite signals properly, and as a result, we will not get valid location data such as latitude, longitude, altitude or time. Therefore, before testing the GPS module, make sure the antenna is connected securely so the module can acquire satellite signals and provide accurate GPS information. First, we will connect the new 7M GPS module with Arduino. Connect the GPS TX pin to Arduino pin D2. Connect GPS RX pin to Arduino pin D3. GPS VCC pin to 5V and ground pin to ground. Then we will connect the SSD1306 OLED display. Connect the VCC pin of the OLED display with 5V, ground pin with ground. Connect the SDA pin with A4 and SCL pin with A5. Now let's set up the Arduino IDE. We need two libraries, TinyGPS Plus for the GPS and Adafruit libraries for the OLED display. After uploading the code, now power up the Arduino Uno. I was expecting to immediately see my location on the OLED display. However, that did not happen. The OLED showed altitude invalid, longitude invalid, satellite count 0. The GPS module was powered on, but it was not receiving enough satellite signals. At first, I thought there might be an issue with the code or wiring. Then I connect an external antenna with it. After attaching the antenna, the GPS module started searching for satellites. Within a few seconds, it successfully acquired a GPS fix. The OLED display started showing real GPS coordinates. This is completely normal because GPS module require a clear view of the sky to communicate with satellites. As you can see, the OLED display is updating in real time. The latitude and longitude values are visible. The satellite count is increasing as more satellites become available. Altitude information is also displayed. Since I am not moving, the speed remains close to 0 km per hour. The GPS module is also providing an accurate UTC time and date directly from the satellites. This demonstrates that the new 7M GPS module is working perfectly with Arduino Uno. Today we successfully interfaced the new 7M GPS module with an Arduino Uno and displayed real-time GPS information on an OLED display. We learned how GPS module communicate with satellites, how to process GPS data using the TinyGPS Plus library, and how to visualize that data on a compact OLED screen. One important lesson from this project is that GPS module require proper antenna connection and a clear view of the sky. If you are getting invalid coordinates or zero satellites, don't panic. Simply connect the antenna and give the module a few seconds to acquire a GPS fix. I hope you enjoyed this project and learned something new. If you found this video helpful, don't forget like, share and subscribe for more Arduino, ESP32, IoT, robotics and electronics projects. Thanks for watching and I will see you in the next project.